In this example, we're going to find all the factors of a number, and we're going to use the results from the last problem to help us do this in a more efficient way. Let's read the directions. Find all factors of the given numbers by finding factor pairs. So this is going to be our method. Use the table of perfect squares to see what the largest number you have to check is. Notice I have the table of perfect squares down here. Write your final answer as a list of factors separated by commas. So let's start by looking at the number and seeing the largest number we have to check. So our number is 24. And now let's go to the factor pairs, or the perfect squares. So 24 lies between 16 and 25, and we saw that we only have to check the perfect square, which is 16, that's less than the number we're looking at. So we don't have to check 5 because 25 is larger than 24. The largest number we have to check is going to be 4. So let's write that here. So we want to start with the number 1. So 1 times 24. So 1 is a factor of every number, and the number itself is a factor of every number. So you want to make sure that you start with these so you don't leave them out. Now we're going to continue down like we did before by going up by one number. So we're going up to 2. Okay? So is 2 a factor of 24? Is there some number we multiply 2 by to get 24? And you may know this already, but we're just going to use the calculator and divisibility. So remember we said if 2 is a factor of 24, 24 is divisible by 2. So 24 divided by 2 is 12. So we have 2 times 12. There was no remainder. So 2 is a factor of 24, and we also found another factor, namely 12. Now we've done 1 and 2. Let's go up to 3. Now is 3 a factor of 24? And you may know this already, but let's check using divisibility. 3 is a factor of 24 if 24 is divisible by 3. And it is. 3 times 8 equals 24. So we have 3 times 8, and that's a factor. And the largest number we have to check is next. So once we get to 4, this is the last number we have to check. Is 4 a factor of 24? Well, is 24 divisible by 4? And again, the answer is yes. 4 times 6 equals 24. Now we can stop checking, and remember, if we went up by one more number, 5, we would have gotten the corresponding factor up here because of the square rule. So we found all of the factors, and now we're going to make a list. So what you want to do is make a list from smallest to largest. It keeps it in order, and you can do that by moving down the left column and then back up the right column. So 1 comma, 2 comma, 3 comma, 4, 6, 8, 12, and 24. So these are all of the factors of 24. It has a lot of factors. So notice we did that very systematically. You don't want to just think of, oh, what numbers can I think of that are factors of 24? Here, this method ensured that we didn't miss any of the factors. And then we created our list. Let's look at the next one. Okay. So our next number is 60, and let's see the largest number we have to check. Well, going down to perfect squares, I'm looking for where 60 lies between. So 60 lies between 49 and 64. It's less than 64. So we said we can round down, and the largest number we're going to need to look at is 7. So that's the biggest number we have to check. So let's start. We have 1 times 60. Now we're going to move on to 2. Is 2 a factor of 60? Well, is 60 divisible by 2? I'm not going to go to the calculator just yet because I think we can figure most of these out, but you could always use the calculator to divide. So 2 times 30 is 60. Is 3 a factor of 60? Well, 60 divided by 3 is 20. Next we go to 4. Okay. And this might be one that you think, well, I can't think of a number that I multiply 4 by to get 60, but that's really where you want to be careful. So let's go to the calculator and divide 60 by 4 and see what happens. Notice we get exactly 15 with no remainder. So that means 4 times 15 equals 60. We're going to move on to 5. 60 divided by 5 equals exactly 12 with no remainder. So that means 5 is a factor of 60, and so is 12. You probably know that 6 times 10 is 60. And now we only have to go up to 7, so let's check 7. So if I divide 60 by 7, notice I get 8, and this decimal tells me there's a remainder. So 7 times 8 is 56, so that means there's a remainder of 4. So you don't need to write the remainder, but it's 7 times 8, but plus 4. And since these were all plus 0, they were exact factors, or factors, this plus 4 means 7 is not a factor, neither is 8. So we'll cross it out. And that was the last number we needed to check. So now let's put these in a list. And the factors of 60 are 1, 2, 3, 4, 5, 6, not 7. Wrapping around, we have 10, 12, 15, 20, 30, and 60. So these are all the factors of 60. And stop and take a look and think of all the ones you might have missed if you just tried to make your own list in your head without using this process. You might have forgotten 12 or 15, so you really need to use this process to make sure you don't miss any factors. Okay? And 60 also has a lot of factors. Let's see the next problem. So 124. Let's find where it is in the list. So 124 is between 121 and 144. So we'll round down to the 121, and we have to check up to 11. So we'll start with 1 times 124. Now let's try 2. So we'll divide, we'll use the divisibility rule. 124 divided by 2 is 61. Now let's try 3. 124 divided by 3, there's 41 and a remainder, so that means 3 is not a factor of 124. So we're just going to cross that out. Next, let's try 4. 124 divided by 4 is 31. So that's one I wouldn't have thought of. 4 times 31. Wait a minute, this one isn't right. This was 62. Good thing I'm redoing these later. Okay, 4 times 31. Now let's try 5. And you might notice, I know already that 124 isn't divisible by 5. Notice there's a decimal, which means there's a remainder. And that's because numbers that are divisible by 5 end in a 0 or a 5. So you can use any rules or tricks like that that you remember. Let's move over here and try 6. 124 divided by 6. There's a decimal, which means there's a remainder. So 6 is not a factor. Let's try 7. Also not a factor. Now let's try 8. There is a decimal, so there's a remainder. So 8 is not a factor. We just have a few more to go. Let's try 9. 124 divided by 9. Remainder, so not a factor. We can try 10. Now notice if it was divisible by 10, it would end in a 0. So I know it's not divisible by 10, but let's just use our divisibility method so we can be sure. Now there's 0.4, so there is a remainder. And the last number we need to try is 11. So 124 divided by 11. Well, that's 11, and there's a remainder, so that's also not a factor. So 124 didn't have as many factors as the other numbers. Let's make a list. So we have 1, 2, 4. Now circling back, 31, 62, and 124. Okay, so that was a lot of numbers to check, but just think how much more it could have been if we checked 1 to all the way up to 124. So our perfect square rule really helps narrow down the possibilities, and we get that there are 6 factors of 124, and there they are.